Hello, I'm Mike Tracy, Hypertherm Training Manager. This video presentation is intended to help you get the most from your Hypertherm plasma cutting equipment. You'll learn how to take full advantage of the high-performance characteristics inherent with Hypertherm's cutting-edge torch design and consumable technology. Hypertherm's research and development team is constantly improving consumable performance. Innovations only available with Hypertherm genuine consumables, such as torch front-end shielding, long-life oxygen cutting, electrode technologies like High Life, Cool Core, Taper True, and our latest Silver Plus, as well as high-flow vortex and coaxial assist jet technology, have greatly increased consumable life and improved cut quality. Field visits, however, have shown us time and time again that some basic operating and maintenance procedures are being overlooked, keeping operators like you from getting the full benefit from these technological advances. By helping you to focus on the fundamentals of proper use and maintenance for Hypertherm systems, this presentation will enable you to realize longer consumable life, greater productivity, enhanced cut quality, and substantial performance benefits. So let's start by looking at the factors that promote long consumable life.
Consumable life is not an exact science and may differ from one application to another, depending on what is expected from the cut. There are many variables that affect the usable life of consumables: gas purity, average duration of cut, number of pierces, and compliance with the manufacturer's recommended cut parameters, including pierce height, flow rates, pierce delay, output current, and arc voltage. These are some of the most important. Also critical, of course, are the quality requirements of the user. Because it is virtually impossible to predict nozzle and electrode wear rates for specific applications, we must speak in terms of average life. Tests have shown that Hypertherm long life can achieve electrode life 4 to 6 times longer than standard oxygen plasma cutting systems, an advantage that is even greater on long life systems using Hypertherm's new Silver Plus electrode. Because consumables wear at different rates in different applications, replacing them prematurely is a key contributor to excessive cutting costs. While electrodes and nozzles should generally be replaced as a set, this may not be true in all applications, so make sure you inspect them closely for wear before deciding to discard them. We recommend switching out all standard copper electrodes when the hafnium pit depth reaches 40 to 50 thousandths of an inch, or approximately 1 millimeter. Bimetal Silver Plus electrodes can wear twice as deep. Swirl rings should be replaced when necessary, usually every 5 to 10 electrode and nozzle changes. Shields, retaining caps, and other parts only need replacing when they are visibly worn or when cut quality decreases. Always select consumable parts using the appropriate cut chart and use only the tools provided in your parts kit. Lubricate all O-rings with a thin film of silicone grease by applying the lubricant to your fingers and rubbing it on the O-ring. Too much silicone can impair parts life and cut quality. Recording consumable life is very important, as it lets you see when you're having problems, thereby allowing you to troubleshoot more effectively. Always make note of the acceptability of the cut part. Your log should be filled out every time consumables are changed. Consumable life can be increased by following these steps. Pierce height should be 1.5 to 2 times the correct torch-to-work distance during cutting. Piercing too close to the plate causes blowback slag to enter the torch, which will in turn cause double arcing, resulting in excessive nozzle wear. Piercing too high will cause excessive pilot arcing. Make sure that you start and stop the cut on the plate. Do not run the arc off the plate, as this will create ramp-down errors, where gas pressure and current terminate abruptly. Every error equals approximately 10 to 15 pierces lost in the long life process. Nozzle and electrode life can be dramatically reduced by a poor ground, so make sure that your table and plate are properly grounded.
Cut quality is always an issue, so let's look at the key factors that contribute to good cut quality.
There are 4 basic measurements used to determine good cut quality: bevel angle, dross levels, appearance of the cut, and lag lines. Always adjust the torch to make sure that it is square to the plate. This helps to ensure the angle is uniform and minimized on all sides of a cut part. Cut angularity is directly affected by changes in torch height. Proper torch height is critical in order to ensure that a cut does not have a bad bevel. If a bevel angle is negative or concave, the torch may be too low. If the bevel is positive or convex, the torch may be too high. Torch height can be adjusted by changing arc voltage settings. If spatter appears on the top edge of a cut surface, lower the voltage in increments of 5 volts until the dross disappears. Fine rollover dross that welds to the bottom edge is called high-speed dross and can be eliminated by decreasing cut speed. Globular dross that forms in large deposits and comes off easily in large pieces is called low-speed dross. It will disappear when cut speed is increased. Observing the lag lines of a cut is an excellent way to determine proper cut speeds. As shown, correct speed produces lag lines that trail at an angle of 10 to 15 degrees. When the speed is too slow, the lines are more vertical, as this example shows. When the lines are trailing drastically, the speed is too high. When cutting materials other than mild steel, lag lines can also be used, but must be read differently. For example, proper cutting on stainless steel results in lag lines approaching 30 degrees, with similar results on aluminum. Other factors used to assess proper cut speed are bevel angle, dross levels, and surface appearance. As cutting speed increases, arc voltage decreases, and vice versa. Cutting speed changes when going into and out of corners, at the beginning and end of a cut, and when cutting circles and contours, all of which can cause dross. In addition, the torch will dive as speed decreases and rise as it increases. The torch height control must be turned off while going in and out of corners to avoid this phenomenon. Turning the control off is called corner lockout. This is an automatic function on most modern CNC controls. With conventional plasma, one side of the plasma cut will always have a very pronounced bevel. The bad side of the cut is the result of the swirling action of the plasma gas. The good side should be toward your production piece, that is, on the right as the torch travels away from you. This phenomenon is not nearly as significant in high-definition cutting. Another factor to consider is the trade-off between cut speed and cut quality. Hypertherm cut charts are developed around parameters that generate optimal cut quality and reasonable speed. Not all applications, strip cuts for example, may require this level of cut quality. In these cases, higher cut speeds may be possible at the expense of increased cut angularity, decreased edge smoothness, and possibly high-speed dross. These trade-offs are at the discretion of the end user.
Selecting the right gas is critical to the proper operation of your plasma cutting system. So let's look at a few guidelines to consider when choosing your process gas.
The gas should be free of any contaminants. Plasma gas, also called the cutting gas, is ionized and exits through the nozzle orifice. Shield gas is the secondary gas, and it surrounds the arc to help constrict it, while at the same time cooling the torch. Oxygen is best on mild steel, allowing higher cut speeds, a larger dross-free window, and eliminating nitriding of the cut edge for improved welding. Nitrogen is the most common choice for aluminum and stainless steel. Air is the universal second choice for most materials.
Now let's look at some common consumable wear problems and their causes.
If the electrode erodes quickly, causes can include gas restriction and low gas flow in the system. You will need to verify the flow setting to be certain it is correct. Also, make sure that the proper consumables are being used. Check the swirl ring to assure it's not broken or over-lubricated. Check the hose and valve for constrictions and proper function. High coolant temperature or low coolant flow may also be the problem. So verify that the temperature is what it should be and perform a coolant flow test. Remember, optimal long life cutting requires a controlled ramp down of gas flows and current at the end of the cut. So check for excessive errors and, if necessary, make programming changes to allow the system to ramp down properly. Frequently, This means eliminating a lead out when cutting holes. Electrode erosion is much more prevalent if you have greater than 10% ramp down errors. If this does not correct the problem, and electrode pit wear is non-concentric, a new swirl ring may be required. When the nozzle orifice wears out of round, or the orifice wears from the outside in, it could mean excessive double arcing. Verify that the pierce height is correct, and check the work cable connection for a proper ground. Finally, check that the pilot arc is functioning properly and not remaining on too long. If the nozzle erodes on the inside or the electrode tip blackens, the cause may be gas contamination, and you should check the gas supply for leaks. Double arcing may also be a cause, and so pierce height should be checked to make sure it isn't too low. Improper maintenance can lead to major problems and result in unexpected and costly downtime. Routine maintenance can maximize cut quality, consumable life, and product reliability. Most importantly, it will increase productivity. Because proper maintenance is critical to efficient, low-cost system operation, a maintenance section is included in each operator manual. Hypertherm has also developed a separate preventive maintenance protocol, which is available at no charge.
So you can see, routine maintenance is critical to optimum system performance. Here's a brief summary of a few key maintenance checks that will help you achieve the greater productivity, enhanced cut quality, and substantial operational savings mentioned at the beginning of this presentation. Each day you should check inlet gas pressures and gas flow settings. You should also check coolant pressures and temperatures, inspect the torch, and replace consumables as needed. Every week, clean the power supply with compressed air or vacuum. Verify that the cooling fans are working properly. Clean the torch threads and current ring with a cotton swab and check to see that the coolant is at the correct level. Beyond these few key checks, Hypertherm recommends a regular, monthly, and semi-annual maintenance procedure. These are described in detail in both your operator's manual and the machine side reference guide, another reference tool free from Hypertherm. I hope this brief presentation will help you to increase productivity and lower cutting costs. However, I suggest that you take full advantage of all the materials available to you, such as the machine side reference guide, preventive maintenance protocol, cut quality and consumable wear posters, and other materials offered free by Hypertherm. In addition, your factory-trained Hypertherm supplier will be able to answer any questions you may have. Or you may contact Hypertherm's technical service directly. Bottom line, the more you know about your Hypertherm plasma cutting system, the more you'll get out of it. Thanks for watching.